Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I'm Arif and I welcome you all to the next section of the lecture series on Internet Working with Linux. Today we are going to talk about Internet's domain name system. Most of you might be knowing that DNS is a hierarchical, decentralized naming service that runs on hundreds and thousands of computers all around the globe, and are responsible for mapping host names with their IP addresses and vice versa. Today we will discuss the concepts and important related terms to prepare the ground of our next session, which is on installing, configuring and using Bind as a private network DNS server. Dear students, we all know that humans can be identified in many ways: by their first name, last name, nickname, as well as by their national identity numbers, their employee numbers, or maybe their roll numbers. In a similar fashion, the hosts on the internet can also be identified either by their host names or by their IP addresses. The string-based host names are easy to remember by humans, but difficult to process by the machines. Therefore, the internet needs to have a directory system that can map a host name to an IP address. And this is analogous to a telephone directory which maps the names of our relatives and friends to their respective telephone numbers. Excuse me. Having said this, let us explore the history to put the stage right, the history of DNS. If we go back to 1969, when Internet was born, there were 4 hosts located at University of California, Los Angeles, University of Santa Barbara, University of Utah, and Stanford Research Institute, which were connected via 56 kbps phone lines. Well, students, remembering those 4 IP addresses was not an issue at that time. However, in 1971, just after 3 years, the count of internet hosts moved to thousands. At that time, the idea of a host lookup table was introduced to keep the name and IP mapping over there. Finally, in 1984, the idea of DNS was proposed and later implemented. But before I talk about the working of DNS, let us first see how the host lookup table concept actually works. Our lab environment for today's session consists of the same 3 machines. Right now I'm on the Ubuntu server machine, hostname. The IP address is 192.168.1.100. This is my Kali machine running Kali Linux, and the IP address is 192.168.1.101. And this is our Windows 10. The host name is, of course, Windows 10. And the IP address, as you can see, is 192.168.1.103. So all these machines are on the same network and of course can ping each other using the IP addresses. What if we want that these machines should be able to ping each other using host names as well? Well, for that, we need to populate the local host lookup table on all these machines. To save time, I have already done it. Probably we done it in the previous session as well. On the Ubuntu server machine, let me cat etc host. You can see this file. It is having the entries for Ubuntu server, Kali, WinXP as well as for Windows 10. Let me move on to Kali and cat etc host. Over here as well you can see these 4-5 addresses which I have managed: 100 for Ubuntu server, 101 for Kali, 102 for WinXP and 103 for Windows 10. Similarly, if we move on to the Microsoft Windows 10 machine, The host file is located in, let me go into PC. In C we have the Windows folder, and in the Windows folder we have the System32 folder, and inside the System32 folder we have the drivers folder, and inside the drivers folder we have the etc folder, and here we have the host file. So let me open this host file in Notepad, and you can see again here are the 4 entries which I have made. So I have made the IP and the host name mapping in all these machines. So if the mapping is there, so that means we can access every machine using the names. So I'm accessing Ubuntu server, and I'm accessing Windows 10 from the Kali machine. Similarly, from the Windows 10 machine, I can easily ping Kali. Okay, so things are working, it's fine. Well, dear students, this technique of mapping host lookup tables on all the hosts worked fine in the early years of internet, but it do suffer with a lot of problems. For example, if we want to add a new host, we need to put its host name and IP mapping entry in the lookup tables of all the existing hosts. So if there is another machine, let's suppose machine 2, we need to put its IP and name in the etc host file on all the machines on the network. Similarly, if the IP or the host name of a machine changes, you need to reflect that change in the lookup table of all the hosts. A lot of improvements were proposed, but due to sheer size of the internet and its rate of growth, no promising solution came up till 1983. And in 1983, the first RFC for DNS was published. Okay, let us move on to a browser and see what an RFC is. Well, right now I'm on the home page of Internet System Consortium. You can go to Community RFCs. Sorry, Community. Let me go to Community. And RFC, let me go to DNS RFC. Well, this page displays the links to all the requests for comments for DNS that has been published so far. So you can see that. Lot of pages, lot of DNS. Okay, for those who do not know much about RFCs, they are actually documents that specify and discuss current and developing standards for the internet. These documents are first published as drafts and are made available to the internet user for review and feedback. After review, some of these become standard, while you can see on the page that some are just for informational and experimental purposes. Let me open these first two RFCs, RFC 882 and RFC 883. Okay, well, this RFC 882, let me zoom it. It was published in November 1983 and deals with domain name concept and facilities. There is plethora of information in these RFCs. I strongly recommend, if you want to learn about some internet standard, you need to go through these RFCs. Well, this RFC 883 also came up in November 1983. It deals with domain names, implementation and specification. Of course, these are obsoleted by these two. Oh, well, if you want to dig out the real details about how DNS works, these RFCs will be of great help. Whenever you have time, do visit the main page of Internet Engineering Task Force as well, ietf.org. This is an open group of individuals responsible to design and test new technologies for internet and the famous TCP/IP suite as well. Okay, dear students, before we discuss how DNS actually works, we need to understand the concepts of hierarchical namespace of DNS. And for that, let me move on to the board. Okay. Hierarchical, let me move this to some color. Hierarchical namespace. A host on the internet can be uniquely identified by what we call a fully qualified domain name. Fully qualified domain name, FQDN. And an FQDN can be divided into two parts: host, host name, then there is a period, and then we have the domain name. Well, this host name identifies a host on the network, and this domain name it may consist of two or more strings separated by a period. Let me take an example. pu.edu.pk. This can be an example domain. Well, dear students, there is a central authority that manages the assignment of these domain names to different organizations, and that is ayana.org. You can visit the main page of this organization, Internet Assigned Numbers Authority, and they do have the assistance of different companies called the registrars, which actually assigns the domain names. Well, an organization can always use prefixes to its domain name to define its host. For example, there is a host 1 on pu.edu.pk. There can be a host 2 on pu.edu.pk. So different hosts can be added to the domain. Similarly, an organization can also add suffixes to its domain name to define the resources. Let me say pu.edu.pk/home/faculties. Well, this page might refer to another resource where the faculties, information about the faculties of PU are there. You can visit these locations. Let us move on to another board and see how this namespace is actually structured. Excuse me. Okay. Once again, let me write down the structure. At the very top, we have what we call the root. And there is a huge tree which is structured with the root at the top. You can think of this entire domain name space as an inverted tree with this root at the top. And this is represented by a period. Below the root, we have about 760 or more top level domains. We normally call them TLDs. top level domains? Well, dear students, there can be generic top level domains like like MIL military, COM for commercial organizations, EDU for educational institutes, ORG for non-profit organizations, GOV for government organizations, and so on. So these are called generic top level domains, GTLDs. Similarly, we do have country code top level domains, CCTLDs. And they are PK for Pakistan, UK for United Kingdom, US for United States, CN for China, IN for India, and ME for Montenegro, and so on. And there are others as well. For example, under this COM, we can have google.com, we can have ubuntu.com, and so on. Similarly, let me draw a tree below PK, and if I draw a tree below PK, we can have COM over here, we can have EDU over here, we can have GOV over here. These are called second level domains. So these are the root, TLD, and second level domains. Well, below these second level domains, again, we can have a lot of subdomains. Let's talk about let me change color. Let me talk about PU. And below PU, we can have further subdomains which may relate to its different departments like PUCIT or math or stat or whatever. And this PUCIT domain do have its own tree, and the nodes can be www, holding the website, maybe the online, maybe FTP, and so on. Oh, well, dear students, this is what we call a domain. We do have a stat domain, and we do have this bigger domain. So they can be domains, there can be subdomains within that. A subdomain is actually a domain that is part of a larger domain. Okay, now if you want to uniquely identify this machine on this entire network, you can name it as www.pucit.pu.edu.pk. You can observe that if we move from left to right in this name, we are moving from most specific to least specific. The www is actually this machine, then PUCIT is the domain name, PU is again the domain name, .edu.pk, and this is finally, this dot is the dot that represents the root server. Okay, dear students, now we know about the hierarchical namespace. If you expand this tree, you can have the idea that there are millions and millions of computers that are there in this inverted tree. And all the names and IP addresses of these hosts need to be saved somewhere. For example, if this is the name of a host, and it must be having a corresponding IP address. And that IP address and this name must be saved somewhere. Dear students, it will be very inefficient and also not reliable to have just one computer store such a huge amount of information. So the solution is to distribute the information among many computers called the domain name servers. Let me move ahead to another board and talk about the distribution of the namespace. Distribution of name space. So we're going to divide this information, huge amount of information, among many computers. At the top level, at the very top level, we have certain machines that we call the root servers. Right, dear students, there are 13 root servers. Okay, let me move on to this, and let me open iona.org, and within that let me go to domains and root and db, and so these are the servers which you can see. These are the TLD servers. So let me see the servers first. Servers. Okay. So these are the 13 root servers. You can see starting from A, and we move ahead. These 13 root servers, as you can see, they are managed by 12 different operators, because VeriSign manages the A root server as well as the J root server as well. These root servers maintain information about the TLD servers, and we have just visited the TLD servers as well. So you can visit the TLD servers as well from the IANA site. And let me move back to my board and write down that these 13 root servers, A dot root server, B dot root server, and so on to M dot root server. These root servers know where the TLD servers are. So below this we have the TLD servers. The top level domain servers, they maintain information actually about the domain servers. So there are a lot of servers over this level as well. And below this we have the actual domain name servers. Domain name servers. These are the actual servers which maintain host name and IP mapping information in files called the zone files. We'll talk about the zone file in detail in our next session. They have the actual mapping. These are the servers which have the actual mapping. And below them we have a lot of other servers which we normally call the forwarders or the resolving name servers. These do not maintain zone files. They just query the domain servers and cache the DNS records for further use. Let me take the opportunity to touch upon another term that is known as authoritative nameserver. Well, if a DNS server has the complete updated zone file of a domain, then that DNS server is called the authoritative name server for that domain. And of course, it also needs to keep track of the authoritative name servers of its subdomains as well. And if a name server just is caching the resource records of a namespace and is not maintaining the zone file in completeness, then it is called a non-authoritative name server. Okay, now we have a fair idea of how the namespace of the DNS is spread or distributed across multiple machines all around the globe. Now let us try to understand how the name address resolution actually takes place. Let me move on to another board. Let me write down name resolution. And let's suppose that I have an address www.pucit.pu.edu.pk. Let's suppose that this is a machine at my home on which I am sitting right now. I open a web browser on it and write down this IP in the address bar. Okay, my dear students, the web browser actually invokes the local resolver. Which is an operating system module. And the local resolver checks its cache or the local host lookup table in the etc host file to see if the name has a static mapping. If found, it returns the corresponding IP address to the browser, and the browser then commences an HTTP request to that IP address and gets you the page. Let us assume that the mapping is not found in the etc host file. Then the resolver generates a query and send it to the local domain name server. Let me draw that server over here. This is the local domain name server, or you can say it is a default domain name server, or you can say that this is a proxy server. So the resolver generates a query and sends it to this local domain name server. And every machine which wants to access the internet must have the address of a local domain name server. You can always move on to Kali and see that. Let me do that for you. Let me move on to our Kali machine over here. And let me do sudo route -n. You can see the address of the gateway 192.168.1.1. You can also do cat etc resolve.conf, and this file also contains the address of the name server, and that is 192.168.1.100. So every machine which wants to access the internet must have the address of at least one name server over here. Okay, let us move back to the board. Well, fine. If the local name server do not have the IP address corresponding to this name, it generates an iterative request to one of the root name servers, which return the address of the TLD server. Okay, let me draw it. So it generates a request to a root name server. And of course, root name servers do not maintain mapping of these actual machines. It just returns you the address IP of the .pk server, this part. Finally, the local DNS server sends another query to the .pk TLD server, this TLD server, which of course returns the IP of the .edu.pk server, and then again it sends a request to actually the name server, which returns the IP address. So this is known as the authoritative name server. If it do have the zone file, or if it has cached that IP address, then it is known as the non-authoritative name server. But anyway, that IP address is returned to our host. So the local name server returns this IP address to the resolver on the local machine, which adds it to the cache for future use and gives that address to the browser. And then the browser actually commences an HTTP request to that IP address, and this is the machine, that is www.pucit.edu.pk, and of course it sends back the HTTP response to our machine. Also, this is how the name resolution is carried out. So before I move on to the terminal again, let me briefly touch upon what is a DNS resource record is. DNS resource record. Well, dear students, every name server stores information about a domain in a file that is known as a zone file, and every zone file contains information about a domain in a 5-tuple data in a structure that is known as resource record. The 5 tuples in each line is the domain name, then a space, then a time to, okay, let me rub it. The next field is time to live, then we have class, then we have type, and then we have a value. Let me write down some examples and then I will describe. Maybe I don't need to. Google.com, let's suppose 112 in a 216.58.208.78. Let's take the other example of my website, arifpat.me, 263 in a 198.54.116.5. Excuse me. Okay, dear students, this domain name is self-explanatory. This is the domain name that identifies the resource record. This is the value time to live. This is the time in seconds for which a receiving server can cache the information. After this, the mapping becomes invalid, and any query must be sent again to the authoritative server. This is the class, and we are just interested in the internet class, so IN is there. This is the type. Well, this is important. This defines how the value over here is interpreted. And this type can be A, which means the value over here is a 32-bit IPv4 address. The type can be AA, which means the value over here is 128-bit IPv6 address. The type can be NS, meaning the value is authoritative name server for a zone. The value can be SOA, which marks the beginning of a zone, start of authority. It can be MX, means the value is the address of a mail server. It can be PTR, which means for reverse query of DNS. It can be CNAME, that means canonical name, a name to name mapping, and there are others as well. Well, that is enough for this. Let me put the board aside. Okay, and let me move on to the terminal again. Let me move on to Kali terminal. If you want to use some utilities, lookup utilities for DNS, you can install sudo apt-get install DNS utils. I'm just trying to map some concepts which we have just learned. The first command that you can use is host. Well, this is a utility that performs DNS lookups, normally used to convert names to IP addresses and vice versa. So we do host arif.me. It's not working. It has worked. Okay, the address is 198.54.116.5. Let me find the IP address of google.com as well. Host google.com. Well, the IP of google.com is also there. Well, this is a very simple utility. For google.com, you can see the addresses, IPv6 address is also there, as well as the mail addresses are also there. The other utility, which is a better one, is NSLookup. NSLookup. Okay. So this is also a name server lookup. This utility is available for all Unisys as well as for Microsoft platform as well. Let me do NSLookup for arif.me. Well, this will return. This is saying can't find arif.me. So let me try google.com. I'm having a slow internet connection. That is why it is not responding. So it has responded for google.com. So remember, the address of the DNS server, this is the address of the server that our system is configured to use to translate the domain names to IP addresses. And well, this 53 at the end is the standard port number on which DNS server accepts the queries. This non-authoritative answer we have already discussed. This means that the DNS server which has responded does not have the zone file itself, or rather have answered the query from its cache. Well, the third command that we can use is dig. Dig is domain information gropper. I personally recommend this one over the last two. Internet System Consortium also recommends dig over NSLookup because dig uses the OS resolver libraries, while NSLookup uses its own libraries. Let me use dig for digging out. Let me dig google.com. Once you run google.com, you try to dig out, you see different sections in the output. The first section over here, this is the header which displays the dig command, its version, some global options that are used, and you can also see a few additional header information as well. Well, anyway, the section of our interest is the question section. You can see the question we asked. This type A means we are interested in the IPv4 address. We can also ask for other types as well. For example, Tetra A, SOA, and so on, which we have just discussed. And this is the answer section. And in this answer section, you can see the resource record, the 5-tuple resource record that is returned to us. The google.com, the TTL, the internet, the A for the IPv4, and this is the actual value over here. You may find sometimes the authority and the additional sections as well, but over here we have the statistics section, which displays some statistics like the query time, which is 3150 milliseconds. Type AAAA, which is for the IPv4 address. So you can see over here we have the type is this and the value is IPv4. Similarly, we can use the MX option over here to find the addresses of the mail servers. Okay, let me clear screen again. I can use NS over here to find out the addresses of the name servers for Google. You can see the name servers over here. Let me clear screen again and let me use SOA and let me do plus multi-line for better readability and understanding. Oops, it has not displayed that actually, but anyway. So you have an idea of how to use dig commands to dig out the DNS information. You can see different resource records, and finally let me do the reverse lookup as well. Let me do dig redhat.com, and if I do dig redhat.com, I will get the IP of the redhat.com. That is this one. This is the IP. Let me copy this IP and let me say I want to dig, but I want to dig out the name from this IP. So we will of course get the resource record, that is this one. You can note the PTR over here. This is the type PTR that is used for reverse lookup. And finally, let me do trace as well. Dig google.com plus trace. The trace option enable the tracing. That is, it will do iterative queries to resolve the name being looked up. You can see it will start from the root servers, showing the answers for each server that was used to resolve this lookup. So you can see from A to M there are different root servers. It is queuing them, and probably my net is a bit slow. That is why it is trying to get it but not resolving it. But anyway, if you run it at your pace, you will of course find a line at the very end which will give you the IP of the google.com. Let me close this and let me say that that is enough for today. I think I have prepared the ground for the next session in which I plan to install, configure and use the bind9 server to act as a private network DNS server. See you then, students. If you have liked the session, do subscribe my YouTube channel and share it with your friends. Happy learning and Allah Hafiz.